Swinburne University of Technology.
So thanks for coming back. We have four short talks again, that are capability based. So we'll be having Steve Manos talk about cloud-based compute and data storage, and then David Flanders talking about Research Bazaar. And then we have Julie from the ITS Project Office, who will talk about some of the services they provide, and perhaps an example of where a ITS project officer or ITS manager has been embedded into one of these e-research projects. And then Jarod Hurley will just give a quick kind of supercomputing technical talk. And then we'll just go straight into the panel discussion. And so the speakers who have come back for this session, we've got some seats around the corner which we'll bring out the front. We've got a whiteboard and we'll start talking about things. So let's get straight to it. So this is Steve Manos from Melbourne, talking about cloud-based services.
Anna, thank you for having us here today. I am here to talk to you about some developments over the last few years of building and operating cloud and storage services in Victoria and nationally for the Victorian research community. A lot of this stuff has been funded through things like organisations like the Victorian government. A majority of it has come from super science funding from the Commonwealth, as well as Monash University, Melbourne University, and a range of other partners nationally. The acronyms or names of the two things I want to talk about today are Nectar and VIC Node. And I'm going to kick off with Nectar. So there's been a lot of discussion today about how to get access to servers, how to get access to cloud resources, and this is a really quick 5-minute talk. There's actually quite a lot I could tell you about the Research Cloud, but the important points are really listed on this single slide. You can get instant access to virtual machines, varying sizes, varying memory configurations. You can start up a single server. You can get access to hundreds of servers. They're hosted out of Melbourne University and Monash University, as well as a number of other sites around the country. All the acronyms are really listed down the bottom there. The Research Cloud is supported by a dedicated support desk. There are people you can contact if you need help, if something's broken. And you can really run anything. You can run a web server, you can run a database, you can run simulations. And the great thing about the cloud is you can actually run your server anywhere in the country. If you need to run it next to the ANU supercomputer, you can. If you decide that you want to shut that server down and run it next to VLSCI or run it somewhere closer to Swinburne, you can do that as well. The awesome thing is that it is built with collaboration in mind. So it's structured around projects, and you can actually share servers with your collaborators, which is something that you couldn't really do without the cloud unless you kind of packed up your server and shipped it somewhere. And the great thing is it is a cloud dedicated to research, so it's there to serve the needs of the research community and to evolve according to the needs of the research community. And if you've got your laptop in front of you, you can probably just go to dashboard.rc.nectar.org.au, log in with your Swinburne credentials, and you can start up a virtual machine for free and get going right now in like the next 2 minutes. So it is really easy entry, and it's really easy to get on board and start running stuff. You're not going to be the only ones actually using the Research Cloud. It's a really, really diverse community. It's been operational since February 2012. There's nearly 5,000 users on the Research Cloud now from a range of organisations and research institutions around the country. There are 624 projects as of yesterday hosted on the Research Cloud. You know, most of those projects tend to be around disciplines like physical sciences and biological sciences, but it's safe to say that all disciplines are reasonably covered in their usage. The National Cloud consists of about 16,000 cores of capacity, and you can just see from the graph there of the fact that there's virtual machines that are running, you know, on Melbourne, but also at other sites around the country that host the Research Cloud: Monash University, QCIF in Queensland, the eResearch South Australia, NCI at ANU, as well as the latest and greatest node, which is the one down at TPAC in Tasmania, with 2 more to come online, being IVEC and Intersect up in Sydney. That's cloud services, and the other thing related to cloud services is data storage services. And Melbourne and Monash universities have partnered to build data storage services for the Victorian research community. Those data storage services run in Victoria. They are hosted out of the University of Melbourne and Monash University data centres. And it's really a comprehensive set of data storage services built with researchers and research collaboration in mind. So one of the big differences between enterprise kind of IT systems and research systems is enterprise is built with the university in mind. It's to lock things in, but researchers don't work in that way. So the cloud infrastructure and the services I'm talking about and the data storage services are built with collaboration in mind. So it's a place to host data collections that are important to you, your research group, your university, your activity, your discipline, your domain, your research group, or just you personally. And it's a place where you can share data, and it doesn't have to be completely open. You can retain access control to that data as well. And it's closely tied to things that might mean something to some of you, like Massive or the Australian Synchrotron or VLSCI, because they're the sorts of things that generate a lot of data that researchers want to keep. And of course, VIC Node is actually part of a broader RDSI network, which again is made up of a number of nodes around the country which have built similar data storage services. All these services are live and available today, and they have been available for a number of months. And there's, more like Vault type services, which are on the left-hand side of these columns, that are more kind of archival type services. And if you want high-speed access to disk, there are those sorts of services available as well. All of these storage services are co-located with high-speed network entry points, so you can kind of move data around quickly, but also they're co-located with the research cloud. So if you need to run virtual machines on top of your data storage, you can do that out of those operating centres. So how to get involved in VIC Node? Well, there's a national merit allocation scheme that's running through till September 2014. In Victoria, we've had about 30 applications go in that have been awarded in the National Merit Scheme. I can't remember the exact figure, but it's something around 30 collections and 2.5 petabytes of data so far, of data collections, with a lot more to come. The last round of that scheme closes on the 12th of September, so I encourage you, I'll give you the details at the end of this talk, on applying for that and thinking about how you could get involved in VIC Node. There's actually two schemes. One of them is the national scheme supported by RDSI, and the other one is the Victorian scheme supported by DSDBI. And it's not just about merit schemes. You can also get access as an institution, as a research group, by paying for the service or subscribing to the service. I won't go into these two case studies in detail, but really these case studies are simply up there to just show that there are plenty of examples where people have a very typical scenario like this one, where they're manually managing data, they're not really backing it up, they're storing it on hard drives on a shelf and CD-ROMs in a drawer, and nothing's in the same place. So being able to move that kind of disorganization of data into a more organized state is one of the things that VIC Node infrastructure is there to achieve. And here's just another example from another discipline, the Melbourne Materials Characterization and Fabrication Platform. And this is more about collaborating around data and giving people access to data online through tools like iCloud. So all of these things are possible. So the places to get more information, to find out how to get access, is the nectar.org.au website for the cloud and the vicnode.org.au website for data storage. If you have really difficult questions, send them to Matthew. And if you have easy questions, send them to me. But really, if you need any more information, any more help, please get in touch. Steve Cornett is up there, and he is responsible for the Nectar Research Cloud node at Monash and the RDSI services or the VIC Node services at Monash, so please speak to him today as well. And we're really here to work as Melbourne and Monash University with the Victorian research community in this space, so please get in touch with us either via those websites, through Matthew, or us personally. Thanks.
Thank you. Do we have any questions for Steven? Yes, if someone can give a mic to Amanda. A mic over there.
for publicly funded Australian research, so as long as it fits within that remit and it's related to something like that, then that's really the cut-off point. So if it was a private company wanting to do research, sorry? NGO? If the NGO was collaborating with an institution, then yes. But an NGO, I think, independently of any institution or any institutional interest, probably not. Yeah. Yes. Yes. Absolutely. So the great thing about the cloud in particular and the data storage underneath is it's built with collaborating across state boundaries. So people who want to collaborate with people at other institutions, perfectly feasible, and you can do that, absolutely, yeah. And it's done a lot already across all of those projects. Yeah.
I have a quick question, which you might not want to hear. Are there still funding opportunities for kind of large Nectar projects? I know that Darren's Teo project was partly funded by Nectar, and there was a call for projects at some point in the past. Is that scheme still running, or?
So that was funded under the Superscience.
Yep.
Newly established. Oh, sorry. Nectar was newly established under Superscience. So the Nectar program, Nectar funds the cloud program, and we also funded those virtual laboratory type projects that funded ASVO work, the tower work that was done here. There's not an open call around the new funding. We allocated all of that funding through the calls. We have got new funding from the Commonwealth, but that funding has strings around it, which are to operate what we built under Superscience. So we are making funding available to those projects through a scheme, but it's not a new open call. Of course, one of the things we're interested in is making a case to government for the value of continuing to invest in these kinds of projects for the new rounds. But the restrictions around the new funding was very, very limited. So, but we would hope that there's an opportunity in the future.
Okay, thank you, Steven. So now we have David Flanders, who's also from Melbourne ITS Research, talking about ResBaz.
Cheers. This feels like I'm being put a dog collar on me, and I'm going to be zapped if I go too far. Anyways, so yeah, I'm kind of following on from Steven's talk. I particularly like actually how the logo drips into the VIC Node one, because they are very tightly coupled, and it's been funny how government has separated the two of them when they often sit on the same rack and things like that. But the real question is there is a lot of money invested in this, and it's some pretty serious equipment, and of course it's not easy to expect researchers to have all these computational skills to be able to use this stuff. So I'm going to talk a little bit about that. We've started an initiative to help support these infrastructures, what we're calling ResBaz, or the Research Bazaar. So just to kind of give you an overview of what Steven was talking about here, this is kind of a layer cake diagram. You can see that we've got our data services, which include VIC Node. There's also data storage very basically on the cloud. Our compute services, which obviously include the cloud as well as HPC features. And then most importantly, what you see in those kind of in-between layers are, above the data service layer, are the data tools, if you will, that allow you to get data onto the cloud and things like that. So that's a series of tools we're working on training researchers to use. And then above that are the tools which help you process and produce the research from that data, so the graphs or the analysis, the statistics, so forth and so on. And it's really, it's frustrating for me because we're always talking about these hard service layers, right? You know, it's the compute and the data, and yet there's no way not to talk about the soft layers. You need researchers and their brains, probably the most advanced computational machine that we have out of this stack, to be able to interface with this stuff and use it. So that's what the Research Bazaar is, and I'll just go up, and that's kind of my objectives for today. Is what we're trying to do is to try to get other universities all throughout the country to start their own Research Bazaar efforts And so I'm going to kind of outline that. I'm only going to outline a little part of it, an initiative called Software Carpentry, which we're going to talk about. It's only a 10-minute talk. Normally I kind of give a 30-minute talk. And then most importantly, I'd highly encourage those of you who are trying to make the strategic argument for this to talk with Dr. Manos to talk about how we've convinced the University of Melbourne, as you all know, a very intensive research institution, why this is a valuable approach to support researchers in their IT. So like I said, I'm only going to talk about one of the three parts, and it's really just the pedagogy over technology aspects. You know, that's what software carpentry for is that's what I'll cover. But I'll also just quickly say it's really important to realize that the reason we're calling this a bazaar is because traditionally IT departments are very ticket-based. You submit a ticket, they fulfill that ticket for you, the kind of cathedral approach. Come in, say your repentance, get your forgivances, right? Go do your penance. That's not what we're doing. We're doing community. So we're bringing researchers together to help one another. And the truth of the matter is we're never going to be able to provide a help desk where somebody can answer the questions of, you know, a reverse Markov chain using Python library 3.0, so forth and so on. That's insane. So that's our approach. The other two sides, which I won't touch on, are the importance of open science. This community, e-research, we sometimes get dragged down a little bit in the competition side, thinking we're in competition. We're not in competition. The researchers are in competition. This is our chance to rising tides float all boats, teach the skills and methods so that those researchers can collaborate with one another. I feel like we just don't need to be competing as much as we pretend we are. And then finally, and this is why this isn't, Steven and I haven't branded our stuff UniMelb logos, is because we have no desire to close this off to UniMelb. We want and we know our researchers collaborate across Victoria, and one of the coolest bits is that we can travel around and see each other face to face. So all of our training that I'm about to talk about is open to you and your researchers to come along, and more importantly, we want to get you involved so you can put on your own training as well. Okay, so why should you listen to me? Cocky American, horrible accent, so forth and so on. I've spent most of my time in the UK and EU traveling around working for funding agencies, a bunch listed up here. The summary of that is I've seen over $500 million spent in e-research projects via Framework Protocol EU7, the New Horizons program, the JISC funding, worked in the US with NSF, with CLEAR and with DLF. That's a lot of mistakes. I've seen a lot of mistakes in this area, and you all kind of know what I'm talking about. Of course, not allowed to call them mistakes because it's government money, it's all learning. And I guess the most important thing, the real thing that I want to drive home here is that we are not going to build WYSIWYGs which are going to be able to do the world-class cutting-edge research that we want our researchers to do. We have to give them the base tools to be able to invent and make mistakes and learn how to do this themselves. So that's kind of what software carpentry is about. Okay, so to try to get you engaged a little bit, who can tell me what these tools are? Just call them out. IPython, R Studio, Fortran, MATLAB. You got R, that's Galaxy, then AutoCAD, NLTK, Natural Language Toolkit, and TileMill. Does anybody know what these all have in common for researchers? I've already told you, actually. MATLAB isn't, unfortunately. It's close, but what they do is they're all essentially platforms for learning how to code, and they're research platforms for learning how to code. So that's the really important bit. And what's nice about it is, as you see, it covers all of our disciplines. And I believe that from humanities to social science to physicists, we can teach all researchers how to code. Let me go into that a little bit more, because I'm not saying that they're going to be software engineers. What they are going to be is they're going to be software carpenters, and that's kind of the analogy. Software engineers, they'll build you the bridges and the buildings and whatnot, where the carpenters, it's about learning how to put up drywall, right? And that's what software carpentry is it sits in between this big, heavy infrastructure we're providing and the skills needed enough to be able to use that infrastructure. I still believe that you absolutely have to have the software engineers there, but they're scarce, right? So we need to kind of up the game of researchers to be able to do this. In terms of immediately getting involved, the easiest way, I can explain software carpentry till I'm blue in the face. Come see it. It's open. Come to one of these events, be a helper, learn how to code yourself. Like I said, depending on your discipline, you can come in and learn any one of those tools. We always do it discipline specific, so that way we can teach researchers in the tools that they use and their colleagues use, along with data sets that their colleagues use, and it's a fantastic way to teach code. Code has been taught really badly because, at least for researchers, not for mathematicians, because when I went through computer science, I was taught according to the way a mathematician would think. The pedagogy, the way you teach someone how to learn something from a humanities background or a social sciences background or a bioinformatician background is completely different in terms of pedagogy, and that's what software carpentry has given us. I'll quickly also just say that it's not just about software carpentry. There's a much broader range of things here, and just to give you the really high overview, you can obviously see Steven's glowing face here. His job as director of the department is to have all those important conversations with those high up in the echelons. They can stop things immediately if you don't get their permission. We also have down here on the long tail the head of our training, Dr. Fiona Tweedy. She helps me manage 6 research community coordinators who do all of this training, and we're looking at about doing anywhere from 50 to 100 training sessions this year alone. It is possible, and it's actually very cheap. I'll talk about that in a second. And then in the middle is a really important group called what we call the A team. So the people, the domain specialist experts, the software engineers often, who are sitting within the department, like neuroscience, who do the MRI data, and helping them do that. So this is kind of the larger spectrum. The thing I really want to drive home to, especially those strategic in the room, the directors in the room, is the fact that a lot of the time you think, I got to spend all my time up here. But what we've seen by actually engaging this long tail is that sometimes people will come to a help desk. They'll come to one of our we call it speed networking of tools, so people can experience tools really quickly. And then they'll come to a boot camp, and then those postgraduates will go back to their directors, and then all of a sudden Dr. Manos will be having conversations with the head of department that he never would have had if we hadn't engaged from the bottom up. So that's really one of the core messages I'd say for that. These are the rescoms that I was talking about. I just want to quickly say that what's cool about this is how cheap it is. So these are all postgraduates, and we pay them on casual, and we have them part-time. It's only about 2 full-time FTEs to be able to have all of this staff and to run up to 100 training events per year. And that engages researchers. That gets people through the door. We've already seen 3,000 researchers because of this initiative. So just lastly, the only thing I'd really hope you take away from this is if you'd like to get involved in software carpentry, the easiest way to do so will be via an event we're running called the Research Bazaar Conference. It'll be in February, 16th through the 18th. And the week before that event, we'll run a Train the Trainer event to train people up in how to be software carpentry instructors. So if you'd like to begin software carpentry at your own institution, contact me, come along to this event, get trained up as a software carpentry instructor, and start doing this stuff at your own institution. It's that simple. Thank you.
Great, that's fantastic. Does anyone have any questions for David? Jarod?
So what's the funding model for this? How do you keep this going?
So right now it's obviously funded through Nectar and ANDS, and Mozilla Science are helping us out on these things. However, in terms of business models going forward, I'm kind of looking at Red Hat. So Red Hat is, for those of you who don't know, it posted $1 billion in profit last year as an open source company. That was mostly due to training. So we know training, and universities are used to this. We don't necessarily think we're going to charge students on a one-per basis to come and have training, researchers on a one-per basis. Instead, what we'll do is we'll keep them free. Then we'll go back to the department and say, hey, 40 of your bioinformaticians participated in this. Do you want us to keep running it? And you'd be amazed how quickly they turn around and say, yes, please. Then we have a conversation around, hey, can you help fund one of the rescoms who run this training for us? So we're not taking any surplus off of this. We're just rolling it back into the department and building relationships directly inside the department itself, which helps people trust us more. And that's always an issue for a central IT department.
Thanks, Flanders. That was really great. So when you do the boot camps, would they be semi-discipline specific, or would you have social scientists and mathematicians in there together?
Anything and everything. We just kind of listen to the researchers. One of our goals is to have the researchers themselves up teaching this stuff. What we do is we always have about 4 or 5 helpers in the room who are Pythonistas or RStudio people or people who know the code. We try to make it discipline specific because, well, so for your example, it'd be perfect. We'd want to run teaching NLTK using an IPython notebook, and we'd want to use the Twitter data set as an exemplar to be able to work with social scientists and humanities people. So I would come to you and I'd say, who's the group of people you want me to work with? Is it just social scientists, or do you want me to bring in finance people or whatnot? It's researcher-led. It's all about the pedagogy of the researcher owning it and them being able to say, this is what I need done with the tools. The other thing I should just quickly highlight, of course, is that all of this stuff is up on the cloud. And what's amazing about that is when you want to go use IPython, instead of me having to take 30 minutes to teach you how to install IPython and the libraries along with it, we have it pre-built in the cloud. We give them a URL. They immediately start using the tool and doing the research rather than having to worry about installations.
Julie, can you come down next? I just have a quick question while Julie sets up her talk. So in the UK astronomy meeting a month ago or 2 months ago, they had a hack day that had astronomers using Python and GitHub and writing code and developing little tools. They were sponsored by GitHub. I'm wondering if there's a possibility that these sorts of hack days could be sponsored by local companies like Atlassian, or do you have any plans for approaching?
In terms of events, it's not a problem. We're getting plenty of sponsors. If anything, it's about turning away sponsors sometimes because they want to be a part of these events because more and more Facebook and Google and all the rest of them are hiring researchers who do have MATLAB experience, who have statistical, because they don't need just Python people, they need somebody who actually knows how to do data analysis. We just literally had a developer hired away who was a MATLAB expert, and they wanted him because they wanted him to analyze the data sets on how to pull Snapchat people away from Snapchat into Facebook, and that's all a data analysis skill. So. For better or worse. Dog collar?
Dog collar time. Oh, I hate these dog collars.
Well, I won't introduce Julie. She can introduce herself.
Hi. So, hello everyone. For those that don't know me, I'm Julie Madjarevic. I head up the ITS Project Management Office. So I asked for the opportunity to talk about us a bit today to let people know that there are actually project management and consultancy services available for researchers. So for those that don't know about the PMO, we've been doing a big program of works, particularly over the last 12 to 18 months, and we've been changing our business model, I guess you could say, to a degree. The major change has been in the fact that we've been lifting our business maturity, working more closely with the research community and working in partnership as well. So we just want people to be aware of that some of the things and the resources, activities that we have underway and the deliverables we have is that for research projects, as well as corporate projects, as well as academic and teaching and learning projects, we can provide project resourcing and full delivery. We can assist with delivery of business cases up to the executive group, such as the Technology Governance Committee and the Research Technology Forums. We can provide business analysis and requirements gathering activity services, looking at different solutions, whether it's cloud-based, application-based, as well, and also coming through to solution design and sustainable support. This part here looks at whether or not we can provide the services on site within ITS, or whether or not we will help guide a research project into setting up a service level agreement with a particular vendor that's going to meet your sustainable research needs. So that's a big difference as well. The other things that we try to look into is the business process model design, modelling and improvement. This could also be looking at the enterprise architecture nature of the, I guess you could say, the technology aspects of your research project. How sustainable is it? What about your coding and your developing? What are you planning on building right now and in the future? What is your vision of your project and how you want it to be maintained as well? So these are some of the things that we look at. We look also about the storage aspects of it. So if you just got the funding now and you think, yep, we've got the funding, it's going to last for, I don't know, 2 years, yep, we can put it through, all good. But do you need to store it for 7 years? Is it medical data? We'll be doing some medical trials where the health act says 75 years. Will that impact your project at all or not? So these are some of the things that we start working with researchers and projects, start asking questions and start the business planning for the full sustainable aspects of your research project. Yeah? Okay, sorry. Other things that we do is we facilitate all sorts of project workshops, whether it's a startup workshop, a risk workshop, an issue workshop, closure, lessons learned to capture and build on maturity for the organisation. We also provide quality assurance. We review requirements, project documentation, assisting with test plans for the development aspect of the deliverable that you want, assisting with the application, with training, where someone may need training and how to work with a particular vendor, because vendor management can either be smooth sailing or it can be a ride over troubled waters. And the other thing we need to do, that we do quite regularly, is look at the projects and how things are strategically aligned, whether it's within the Swinburne vision, the research strategic components, or your teaching and learning components. So some of the examples that we've got here is some of the support we've been working with in the research space over the last 12 months, or 6 to 12 months. So I've been here probably at Swinburne about 12 months and almost 2 weeks, which has been really fun. And so we've been working quite a lot since I've started here with Dr. Neil Thomas's team, the NATC MHO. So the support we've been providing there, I guess you could say at best, is multi-layered. So whether it's governance support, vendor and contract management support, in-house having someone seconded inside the project team as well, working with the researchers, working with the vendors, working through the vendor management aspects and issues and how to get things delivered, looking at hosting as well. It's actually been quite successful for a number of factors. Firstly, we learn more about what the researchers' needs are. So if we know what's going on and we communicate and collaborate, we can actually prepare ourselves and plan better how to support researchers. So that's actually been quite successful. Other things have been is that we've recently started some work with Amanda Lawrence on her new project, which is the digital object identifiers for AND. So far we've been providing just recently some PM and BA support, but more discussions will happen about how that's to continue as well and how the project and program progresses. Other things is that what came through is that we provided some business analysis and service desk support about what happens if the Keck Observatory goes out. So from the astronomy aspect, what happens with that as well, about how to relate with these problems. We're about to implement some applications for the training for biomedical devices. That's happening soon. The other thing is we've provided some, I guess you could say, infrastructure advice as well. And we've also looked into email forwarding for researchers post leaving Swinburne, and also doing some high-level analysis of research systems and contract management. Other work underway is that we've recently had accepted at the TGC our Cloudfirst strategy. So that's a major change for the university going forward about hosting, service provision, anything as a service, as well as engagement project, new HRS project, and other ones underway. And just quickly threw in there about the Research Technology Forum. So I'm sure everyone is aware about it, that you can actually go there and put up ideas, ask advice, talk about what's going on, where you can get additional support. We work quite closely with the research systems area, with Samara and Ryan as well. And so that's been really good for us too. And that's it.
So are there any questions for Julie? Samara.
Hi, Julie.
Hello.
Samara from Research. ITS, particularly here, has a bit of a reputation for being the fun police. So how have you gone about making ITS, particularly the PMO, more approachable for researchers?
I guess you could say we've been working a lot on our website. We've been doing a lot of project roadshows and communication. Sorry. Grab it. We've been trying to get out more, I guess you could say, in between doing our day jobs. So I'm just spruiking the next project's roadshow. We've got Leon Sterling talking. We basically just want to open up the collaboration aspects, I guess you could say. We want to talk more, learn more, work together more. We do actually have quite a few staff with all varied experience. So I know from my previous job, one of my major projects I had under my portfolio was the traffic camera stuff with IMS I had. And from other people as well, they've worked in Oakton for consulting. We regularly meet with Gartner. We regularly review different applications, contact management systems, Drupal, look at how things can work. Yeah.
And I just want to add to that, Rob Shaw is, put your hand up please. So Rob is from the IT project manager's office and was seconded to Mental Health Online as their IT manager. So I would recommend talking to Rob if you do want to know more about how that relationship works and what experience they've had and what were the benefits. Researchers are very good at self-managing, but we're not necessarily great at project management, especially if it involves external vendors and other people.
Yeah, and I guess I should say is that we're realists. One size does not fit all, and that's our approach realistically. If it's a major strategic project through TGC, we have to follow a certain path. If it's a different type, then we follow a different type. We're not saying be prescriptive. We're saying be sensible and flexible.
When did the project management come into being? When did PMO begin?
Well, I guess they had a temporary manager before me, but proper PMO since I started, which was 2nd of July last year, and then realistically about different forms over the last few years. Yeah.
Thanks, Julie.
Thank you.
And now we have just the last speaker, which is Jarod Hurley from Astrophysics, who's just going to give you a little bit more technical information about the G-Star computer for those of you who have thought about using it, particularly social sciences researchers maybe, possibly, who might be able to make use of it.
Yes, thanks, Hannah. And apologies for the colour scheme, which doesn't seem to be too compatible with this theatre. So underpinning a lot of the e-research that we do, either here at Swinburne or with our collaborators, is our supercomputing infrastructure. So I just wanted to give a brief overview of what that is currently. And I can see many people in the audience do have accounts on the supercomputer, so you should already be familiar with a lot of this. And hopefully for everyone else, you've at least been aware that we do have a supercomputing program here at Swinburne. So our supercomputing at Swinburne began roughly in, I think it was 1998, when Matthew Bales started up the Centre for Astrophysics and Supercomputing. So we've had a supercomputer of some sort from that time onwards. The current incarnation is what we, the umbrella name for it is G2. It took over from... That's not going to help. Yeah. All right. Sorry. It'll get clearer after this. So hopefully I will speak to it well enough that you won't need the screen so much. Yeah. So our last supercomputer was green, which we ran from 2007 and started phasing out in 2012. We then got a second life to perform the rendering computations for the Hidden Universe IMAX movie that we produced, but has now been fully retired. So G2 is what we have now. That incorporates G-STAR, which is a nationally funded GPU supercomputer for theoretical astrophysics research. So that's the component funded by the $1 million from EIF that Swinburne secured with the assistance of Astronomy Australia Limited, AAL. So that was combined with the approximately $2 million that Swinburne puts in every 4 or 5 years for our supercomputer major upgrades. And so through 2011, 2012, we put the new facility in place, and it, I think meets our overall goal of continuing to provide a world-class facility for Swinburne research staff and students on which to meet their research goals. So there's a not very interesting picture of what it looks like. It sits up in the fifth floor data center of the GS building across the railway tracks here. And so it's quite obvious from there who the vendor is of the current supercomputer. So this is a breakdown of what is actually composed, or what is actually sitting within those racks. So we have the G-STAR component, mainly comprising 50 nodes. Each node has two CPU sockets, so 12 CPU cores and 2 GPUs. We've heard a bit about these GPUs today, so I brought one along from my office. That's what they look like. Basically, can be a supercomputer that you could carry around almost in your pocket. This is a bit of an outdated one. They're more streamlined than this now. So this, the models, the GPUs we use are, far more than what you would need just to run your day-to-day graphics display on your computer. But they are what your your teenager would love to have in their computer powering their video games. But so they're rough. But what they do provide us, if you can code for them correctly, is roughly 2,000 independent processing pipelines within this device compared to your one CPU core. So it's a way of massively upgrading the processing power you have and providing you with a lower cost per floating point operation. But there is some effort involved in porting your code to make use of GPUs. So they're not for everyone, and we aim for our supercomputer to be for everyone, whether you want to run just code on a single CPU core or a large-scale parallel MPI job across many CPU cores, or whether you want to use GPUs. So our supercomputer is designed with that in mind. That's why we have a mixture of CPUs and GPUs in each of our nodes. We have different flavors of nodes. Most of them have 1 GPU per CPU socket. We do have some that are much higher density in terms of GPUs. So we've got 7 GPUs in a node. And we have other nodes such as CPU-only large memory nodes. And then these are our S-star nodes, which have some more recent CPUs and higher powered NVIDIA GPUs. So there's a variety of hardware all mixed together. It's all combined together with the one interconnect system, a QDR InfiniBand, so everything can talk to everything else, and all connected through to a large Lustre storage system, which is currently roughly 1.8 petabyte in capacity, and will soon be upgrading to approximately 3 petabytes in capacity. So, any questions on that infrastructure side before I move on? Okay, so just to get a rough idea of timelines. So when we purchase hardware, it's generally with a 4-year support warranty. So we generally try and run systems for a lifetime of 4 to 5 years. So our next upgrade will be towards the end of 2016 for the current hardware. So like I said, we're about to do a storage upgrade, so sort of expand the capacity of our storage setup and also extend the lifetime of that. We're adding what we're calling a data sharing cluster, essentially some sort of web servers to easily facilitate getting data out to the wider world from the underlying storage system. And yeah, so likely we'll sort of try and extend the lifetime of the current system through to late 2016, early 2017, which is when we would do our next upgrade, and once again try and take advantage of the latest, greatest technology from the CPU side and GPU side and any other accelerators that emerge in the meantime. Just a quick overview of support. So have an underlying base support from within ITS, from the systems team there. It's a collection of people, but combined amounts to roughly sort of 2 FTE supporting the hardware. I think we have a great supercomputer, but we could definitely have a better supercomputer if we put more money into that support. So there's always more that we could do in terms of enhancing the hardware and the resource. And we have started getting better at, started attracting some additional money for people primarily focused on the astronomy support from sort of government, NCRIS and CRIS programs, capitalising on the E funding of the G-STAR component of the supercomputer. And also some, there's the TAO project that was talked about earlier today in terms of funding for e-research tools that utilise the supercomputer. And I'll just finish up with a quick note on access. So it's open to use by all Swinburne staff, students and their collaborators. Because of the funding model for the current supercomputer, it's also open to all Australian-based astronomers at any national institution, and that guarantees that roughly 40% of the time on the machine can be dedicated to the national astronomy community. Of course, if people aren't utilising that, then the cycles are there for anyone else on the machine to use. All accounts are linked to at least one research project. Many people are members of more than one research project. Currently, we have about 300 individual accounts spread across 70 research projects. And if anyone's interested, I'll just pop up some of the latest usage statistics in terms of demographic and breakdown across some of the research areas in Swinburne. Necessarily still based on the old faculty models because that's what was in place when we set the supercomputer up. So yeah, I'll leave that up and take questions.
So thank you, Jarod. I have a quick question for non-astronomers, or I know there's other groups that do use a computer, but for people who think they might want to use a supercomputer in the future, like social sciences, but who perhaps don't know how to rewrite their code, or even if they have to rewrite their code, or what sort of the technical specifications they need, who do they go to for that? And do we have a lack of support in that area? Is that something we need to build up?
Grey area. So, I mean, the Swinburne support we have within ITS is only just enough just to focus on keeping the hardware running. And so traditionally then it's been left to the researchers to just use the resources as much as they know how to. So lately we have been getting funding, but it's funding tied specifically to support for astronomy use of the machine. But that does bring in people who, can sit down with someone, help write code, help optimize code. And there's a flow on there. Those people, if they have time, are helping non-astronomers as well within Swinburne. But definitely, if there was more money to go into enhancing non-astronomy usage, that would be very welcome, and there's definitely a need for that.
So we have a question up the back from Ewan.
So, Jarod, this may be a naive question, but the running costs and the cost of hardware, etc., for G-STAR, SwinStar, what's the kind of cost gap when you compare that to, say, doing all of the same amount of computation but on the Amazon Compute Cloud? I know there's a huge number of benefits to having everything in-house here, and that's undisputed, but I mean, just in terms of the kind of cost differences between them.
Yeah, well, no thanks for bringing up the running costs, because we don't like to highlight that. Hopefully anyone who cares about paying the bills isn't listening. Yeah, I haven't actually directly done that comparison myself. I would say the program itself, probably if you spread it over per year, combining the hardware costs and the running costs and so on, and people, it's probably costs the university around $1 million a year. Yeah, I'm not sure how much Amazon computing that would buy you, and whether that would keep everyone happy.
Sorry? Okay. So we have questions from Leon and Matthew, and the mics are all...
Yeah, it wasn't a question, it was an answer to Ewan's question. If you want to buy what I'd call gilt-edged disk space on VIC Node, per terabyte, it's around about $600 a terabyte a year. So to have the 2 petabytes of disk would be around about 1.2 million a year for the disk. But their disk space is much, much better than G-Star's in that they have multiple copies of it. So it's not a direct comparison. I think the bigger it is, the more economic it is to have in-house. But if somebody has like 1 terabyte of what I'd call gilt-edged data that's their life's work, then hiring a terabyte on VIC Node for $600 a year is a bargain as far as I'm concerned. If you've got a few petabytes of data and you don't care if you lose 1% of it every now and then, because most of it's worthless, the aggregate of it is what's important, then you're much better off storing it on a local facility. So it really depends on the sort of quality and how much you really want to know it's safe. Yeah, well, we don't generate our own electricity because it's cheaper just to buy it, and there may be a point in time when it might be so easy to just sort of outsource everything that we'd be crazy not to. It's not an easy thing to cost what it costs to run the supercomputer, because we built a gilt-edged machine room with dual UPSs and a generator, and if we didn't actually use any of it, that would have been a very bad investment. But once you actually have all that infrastructure there, then populating it with a few computers actually makes economic sense. We can't go and sell that layer of the building to a third party very easily and get our money back to reinvest it in people, for instance.
My question is, how does G-Star fit in the whole national infrastructure of computing, and is it aligned with other merit allocation schemes or submission protocols, or do we all have different ones? How homogeneous is the Australian system becoming?
Yeah, so the astronomy time on G-Star, well, a large proportion of it is allocated through a merit allocation scheme that's aligned with NCI in Canberra and the Pawsey Centre in Western Australia. So we have a committee run by AAL that actually takes all the astronomy-based proposals for those 3 machines and looks at them all together, and there's an advantage to that, and we can determine whether a particular type of research is more suited to one machine than another. I mean, the researchers obviously have the primary opinion on that. Yeah, so it's certainly, in terms of providing a GPU-focused facility within the national astronomy landscape, it's well aligned with the capabilities of the comparable resources around the country, and we work with those facilities to sort of maximise that the right projects are going to the right areas. Yeah.
Okay, thank you.
This has been a Swinburne production.